Alright guys, this is Mr. Cubic. I'm not allowed to use the classroom, so for social isolation purposes, I'm now moving on to my house. So hopefully you can see this. Today is the notes for Monday. That's April 6th, 2020. We're done with Chapter 10. We're on to Chapter 11. Now I'm going to tell you, I really like Chapter 11, and Chapter 11 is very important. I'd say 90% of it is review. But today we're talking about decimal forms of rational numbers, and your homework is going to be page 515, numbers 2 through 26 even. Alright, so the first thing about a rational number is, a lot of guys, when you think of rational, you think of rational as in making sense, but the root here is actually ratio. So a rational number is any number that can be expressed as a ratio. Okay? So the ratio there, not a ration, as a ratio. Okay? So that is the definition. Okay? So any number that can be expressed in the form of A over B, right? Where we know B does not equal 0, and A and B are whole numbers. Technically, they're integers. Okay, so that's the definition of a rational number. Alright, so it's kind of a big deal. It's one of those things you see the words all the time, and it's just nice to know what they mean. I think you'll find that for the most part, the homework is pretty easy. Okay, so we go ahead and we get started. Hold on one second, I have a calculator, Nate. So we go ahead and we get started, and we have this one. Okay, express each rational number as a terminating or repeating decimal. So I started us off with a pretty easy one, 7 over 2. So the first thing is, you might just know it. That's 3.5. Okay, from having done these since you were in probably 4th grade, I think. The other option you have is you could do the long division. Okay, so you would just do like this. Okay, 2 into 7, right? And the way that you remember this is it is bottom into top. Okay, so 2 goes in there, right? What? 3 times, right? And then we would carry the 1, and it goes in there, right? 0.5, whatever. Okay, and then the last option you have is you can do it on your calculating device, right? So I have one here. So I would just enter in 7 divided by 2. See, on, right? 7 divided by 2, 3.5. Okay, so our answer here is 3.5. Feel free to use your calculator on any of these, okay? But I think you're going to see there's going to be some problems here. All right, now, for this next one, 7 over 200, right, you could do any of these 3 things, right? So you could have it memorized, right? You could do the long division if you don't have a calculator. You could do it on your calculator. Just so you know, it's on your phone, there's a calculator, and you can use Google as a calculator. If you did 7 divided by 2, it would tell you the right answer there. But the other thing you could do is, this is actually 7 over 2 times 1 over 100. So that would be 3.5 times 0.01. So then we would just move the decimal 2 places over, this way, okay? And we get 0.035. So again, you have all the easy options, right? But if you wanted to try and do this using mental math, you could use your brain and say, well, that's 7 over 2 times 1 over 100, and then just move the decimal over from the previous answer. Okay? Just a little something to put in there. Now, 2 more here I do want to talk about. Okay, the first one is 7 over 12. Okay? So, again, I could do long division. I don't have 12s memorized. I think it's probably like 0.83 or something like that. But it'd be bottom into top. So I would do 12 into 7, right? And again, this is where a lot of you guys need to work on your long division. Probably next year will be the last year you ever have to do it. So how many times does 12 go in there? Well, 12 times 6 is 72, so I'm going to go with 5, right? So 5 times 12 is 60. I subtract, I get 10, which is less than 12. I would bring down a 0. How many times does 12 go into 100? Well, 12 times 6 is 72. 12 times 8 is 96. So it's going to be an 8, right? So 8 times 12 is 96. So I get 4. Bring down another 0. 12 goes into 40, right? How many times does it go in there? 3 times, which is 36, right? And then you get a 4, bring down your next 0, and you get 40. So it's going to be with a repetan over the 3. So the answer here is 0.583, right? And we are going to put a repetan bar over that 3. I guess it's repetant. Okay? Two small things here. Okay? The first is that the repetan bar goes only over the part that repeats. Okay? So that's item 1. Item 2. Okay? Whenever I have a fraction that's less than 0, I always start it with 0 point. And the reason I was told this is that whenever you see a 0, you just assume the next thing is a decimal point. So if for some reason you spilled or the pen didn't work right, then you would know that the next thing is that. If you don't do it, I will never mark off. But you should put 0 point and then whatever comes after that. All right, and then the last thing is, for the purpose of this, right, never round unless the directions tell you to. Okay? So there are a couple where I think we're supposed to do some rounding. Okay? But that is not this. Alright? So just a few things. Last thing here I do want to show you on the calculator here, okay, is I have 7 divided by 12. Oops, sorry. Clear. 7 divided by 12. And here, wait, what did I do wrong there? Bottom and the top. 7 divided by 12. All right, now it's right. Okay, so you'll see it's 0.583333. It doesn't end there, right? It's just that the calculator doesn't go to infinity, right? So those ones are really expensive, the infinity calculators, and so we're not going to do that. So you would just put a repeatant bar there. Now if this was 0.66666, that last digit might be a 7, right? And that would just be because the calculator did the rounding for us, but it still probably has the repeatant over the top. Okay, now last one here is negative 13 over 32. Okay, so again, bottom into top, right? So if I did it the short way, it would be 13, right, divided by 32. I don't want to do that, so I'm not going to deal with it. But for you guys, I would suggest just do it on your calculator. 13 divided by 32, right? Enter. Now look, it didn't fill up the whole screen, right? Last time it filled up the whole screen. So this decimal ends after 5 places, right? So on the calculator, we just go in, we go 32, right, divided by, what is that next thing? Or 13 divided by 32 equals, okay? And the answer here is 0.40625. No rounding. Do you understand? No rounding tonight, okay? And I would encourage you to use your calculator unless you want to get some review on your long division. All right, so that's the first thing, right? So then the second thing we do is kind of do the same problem in reverse, okay? So hopefully this thing will, there it is, okay? So it says, express each rational number as a fraction in simplest form. So those are the directions tonight. So this first one is easy, and I'm going to tell you, PJ's actually doing this. I'm kind of proud of him. PJ's doing this in 3rd grade, so I know you've done this for a while. So if I read this, this is the tenths, and this is the hundredths. So, right, PJ has to write out, this is, 56 hundredths in cursive, whatever. Okay, so we know that this is 56 hundredths. So if you write it out, both of these are pronounced the exact same way, right? 56 hundredths, 56 hundredths. Okay? So just so you guys see, that's something that's easy for you guys to do. So here, right, I want to reduce. So what do these both have in common? I don't know. Let's go ahead and go 2, just because that's all I can think of off the top of my head. Okay? So I divide by 2 over 2, and I get 28 over 50. All right, so this one's still even. And so that would give me 14 over 25. And that is the answer. So it's not enough just to make this. We're then supposed to reduce it. One small thing over here I just saw on this problem that I did. Don't forget your sign, right? So I cut off the male part. Sorry about that, you guys. Okay? Now, this last thing is new, and I'm going to tell you this last thing. I know that Mr. Smith shows it to you, but you don't go over it very much. This is one of my favorite things in all of math. I don't know who the first guy to think of it is, right? But whoever it is, he has my undying respect. All right? So the question is, it's easy to change this problem to a fraction. How do I change it when I have the repetant, right? How do I change it if I have 0.444444 all the way to infinity, right? Well, what am I supposed to do there? Okay? So the way I'm going to solve it is I'm going to say let x equal that. Okay, 0.4444444444. All right? And so the next thing I'm going to do is I'm going to say, well, that repeats every one digit. So since it repeats every one digit, I want to shift everything over by 1. Okay? Now, I don't know who thought of this, right? But I do want you to understand that it's pretty slick what he does. Okay? So 10x would be equal to 4.44444, and I could keep going all of the way to eternity because I can. Okay? And I'm just going to subtract from that my original number, 0.4444, and then keep going from there. Okay? Now, I think this is brilliant. And we learned how to do this. It's just like when we did elimination, right? I'm allowed to subtract equations, right? I never thought to do it before. I never needed to do it before. But here's another example where this is really, really useful for us. Okay? So 10x minus x is 9x. And now I'm going to do since this ends at infinity, I'm going to do the subtraction from left to right. Okay? So 4 minus 0 is 4. So now I have 4 minus 4. Well, that cancels. And then 4 minus 4, cancel, 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 cancel. Right? All the way to infinity. Right? All the way to infinity. The whole thing's going to cancel. And this is what you get that's so brilliant. Right? 9x equals 4. There's nothing infinite here. There's nothing that has a repetant bar. All I'm left with is this 9x equals 4. So now I divide both sides by 9, right? And I get x equals 4 over 9. Well, I know that x is equal to 0.4 repeating, so that means things that are equal to the same thing are equal to each other. 0.4 is equal to 4 over 9. So how can I check this? I get out my calculator, right? I'll clear it. I do 4 divided by 9, enter, 0.444444. Okay? So this is an easier one. I really suggest that you go through and you go through this slow. I think I have 3 of these on tonight's homework. All right? So let's look one more. I'll do a hard one for you, okay? And we're going to go slow, and then this will probably take us to about the 20-minute mark, and I think that's fair for our lesson. All right? So I have 0.594. The repetant bar goes over all 3 numbers. Okay? So the first thing I'm going to do, right, I'll do cursive, let x equals 0.594594594, and it goes all the way to infinity. Okay? Now, this one repeats every 3 digits. Okay? So if I want all of this to line up, I need to multiply by 1,000. Okay? I want to multiply by 1,000. Okay, so if x is equal to 0.594, 1,000x is equal to 594.594.594, right? We'll just do all that. I don't need it all. Okay, well, I just figured out, not like 0.2 seconds ago, right, that x is equal to 0.594594594. Okay? So this is at the heart of it. Okay? Now, I subtract, and I get 999x equals 594. Now I'm going to divide both sides by 999, and I get x equals 594 over 999. Now remember, on your homework tonight, you're supposed to reduce. Okay? So here I know the bottom is divisible by 9, and I know the top is divisible by 9. If you forget how I know that, I added up the digits, and then I divide by 9. So I'll do 594 divided by 9 is 66. So I get 66 over 111. Now I know that both of these are multiples of 3. How do I know? Well, they both add up to 3. So if I divide the numerator by 3, I get 22. If I divide 111 by 3, I get 37. 37 is prime, so I'm done. So that means that this fraction is equal to 22 over 37. Let's check. 22 divided by 37, enter, 0.594594.5. So that means that these calculators don't round, right? A good calculator in high school that you have will round. All right, guys, so those are the answers. That should get you started. If you're confused on the second part with the repetant bar, I gave you a link in the Khan Academy. And feel free to please email me, text me, call me, FaceTime me, whatever it is. And if there's a lot of questions, we can go ahead and have a Zoom meeting. So great job by all you guys. Keep staying at it. I'll try and keep my lessons to 20 minutes with about 20 minutes to a half hour of homework. And great job. Enjoy your social isolation. Oh, no. It's physical isolation. But socially, we're still here. Bonding. Social bonding. Spiritual bonding. Physical isolation. Great job, fellas.